All right, so here we're supposed to solve each equation and approximate to the nearest hundredth. All right, so first things first, if we have something to a power, we have to solve to get everything except for, in this case, the e to the x to the other side. So we're going to have to take the 3 over and we're going to have to take the 4 over. So we have to do it in order operations. And so first things first, we're going to take the 3 over, we get the 12. Now we divide by 4 and we have 3. Now we can take the ln of both sides and then we bring our x down. So x is equal to ln of 3 and that's about 1.10. And it says to the hundredth, so we need that 2 decimal places. Okay. Now, what about the next one? Well, the next one, again, does it matter if I use log or ln? No, they both will work, and so use whatever you feel most comfortable with. Now, again, we're going to bring our powers down front, and so now we have something with the power out in front here and power out in front here. But now we have a kind of a sum. So what we need to do is we need to multiply that out and distribute. So we're going to distribute the log here and here. So what we're doing basically is doing that. And so now we have x log 4 and then 2 log 4. And so now we need to get the ones with x's on one side, everything else to the other. So let's take this one to that side. So now we have that. Now what can we do? Well, we can factor out the x, and then we have this, and then it equals still just that on that side. Then we divide by that whole long thing, and then we say, okay, well, let's plug that into our calculator. So when we do that, probably the best way to do that is you're going to have that, you're going to have a parenthesis here and have parenthesis there. And then you want a parenthesis here, 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 and then in parenthesis. So that way, when you put all this into your calculator, you should get the final value of about 1.51. So again, when you're doing these, parentheses are going to be very important when you type these into your calculator. Otherwise, you're going to get the wrong answers. All right. What they want us to do here is solve this symbolically and then give graphical support for your answer. All right, so symbolically is probably the easiest way. So first things we're going to have to get, again, that exponent part by itself. So we have to divide by 100. Okay, well, you divide that by 100, you get 50. Now I'm going to say take the ln of both sides. They like to take the log, so we're going to take the log. So when we do that, we bring the x down in front, and then we can divide by log of 1.3, and we get our answer of about 14.91. Again, they don't tell us what to go to, so make sure you pay attention to what they're asking for to get that answer. Now, graphically, what we're going to do is we're just going to plot the intersection. We're going to say y equals 1,000 is 1, and then we're going to plot the other one, y equals that here, and then the intersection point is going to be 14.910655 at 5,000. Okay, so that's graphical, that's symbolically. Again, this only really works if you're using Desmos or a graphing calculator. Doing it by hand, that's going to be really, really hard. So, okay. Here we're going to solve and approximate solutions to the nearest hundredth when appropriate. All right, so what are we going to do here? Well, how about let's take and divide by 6. That's going to be the easiest thing. Now, we know that if we have our, where's my thing? If we have this as log base 10, we can take 10 to the third equals x. Well, what is 10 to the third? Well, that's equal to 1,000. Okay, and what they're saying is they're kind of forgetting about the basic rule that you can take this to that power equals that. They're saying, okay, well, let's take this whole thing to the 10 power, this whole thing to the 10 power. Then they're using the rule 10 to the log base 10 of x is just x, and so we get that. I think it's easier to say, okay, well, 10 to the third equals x, and we have that automatically. We don't have to worry about this kind of format here. So depends on, again, how you're thinking on what you want to do. Sometimes you're going to have to do this. You're going to have to take e to this power or a to this power or whatever it is and work it out. But this case, it really would just be easiest to do what we have and say, well, 10 to the third is equal to x at this point here, and we get 1,000 equals x. And so it kind of saves us a step. And kind of on the next one, I would do the same thing. I would say take 2 to the 7th is equal to 3x minus 1. And so then you subtract 1, divide by 3, and we have that. But they're saying, well, let's go ahead, take this whole thing to the 2, take 2 to this whole thing. And then when you do that, you're going to end up with 3x minus 1 equals 2 to the 7th. You know what? That's what we got way over here because what we did was when I said it, we're going to take 2 to the 7th equals that. Okay, so they're doing this extra step here. Again, if that makes more sense to you, that's fine. If not, you can do this, and then you can just simplify and plug that into your calculator. Now, if you're doing it in this, you're going to do it in one step. Put parentheses on the numerator so it does everything. Otherwise, you're going to take 2 to the 7th plus 1/3, and that's not what your answer is. It's 2 to the 7th plus 1, all divided by 3. All right, let's stop there and come back for some more.